This video is going to cover a conversation about the fundamental forces that we experience in the world. There are four of them, and these are the four fundamental forces that hold matter together. There's gravitational force, there's electromagnetic force, there's something called the strong force, and there's something called the weak force. So we're obviously going to take each one of those individually and see where they have an influence and how they impact our lives. So for us in chemistry, the gravitational force is actually irrelevant because in order to have a gravity, you have to have something with a huge mass. Since atoms have very little mass, they cannot create any sort of gravitational pull. So of the four fundamental forces, gravity is not one of them that we're going to discuss in chemistry. That would be a physics topic. All right, one that does impact us quite a bit is the electromagnetic force. You've seen that come into play in various areas. It's basically the interaction between charged particles. So if you think about it, you can have similar charges and you can have opposite charges. So you've got different kinds of interactions going on there. So as long as you have charged particles interacting with each other, you get an electromagnetic force. So think about where we've seen this before. These are the forces that hold atoms, ions, and molecules together. And the strength is dictated by Coulomb's law. We've seen this once before. So basically, the force is equal to a constant times the charge of the two particles divided by the distance between them, squared. So you can have a plus charge and a minus charge. You can have two plus charges. Atoms of different sizes are going to result in a different distance. And so that's where our conversation about lattice energy took us last year. If you have greater charge, you get greater force. If you have smaller ions, you have greater lattice energy. So Coulomb's constant is there. So, like I said, the electromagnetic force can be either positive or negative. If the particles have opposite charges, they're going to attract each other. That means the force is negative. The force is pulling them together, and so that's considered a negative force. If they have the same charges, it's pushing each other apart. They're pushing each other apart, and that's considered a positive force. So you have, in the electron cloud, you have electron-electron repulsion. Between ions, you have plus and minuses, and then there should be probably a third one down here, two pluses. In the nucleus, you have protons that are going to be pushing each other apart. So another force that we see take place in the nucleus, so these last two forces are actually nuclear forces. The strong force is the force that holds the nucleus together despite the repulsion of the protons in the nucleus. So the strong force is actually the strongest of the four fundamental forces. Unfortunately, it's only really strong at a very short distance. So as soon as you start piling on more protons and more neutrons, that strong force actually starts to diminish. And without the strong force, you would actually have the nucleus blown apart because of that huge electromagnetic repulsion between all the protons. So the strong force, so you have the protons trying to pull the nucleus apart or force the nucleus apart. The strong force is what holds everything together. So without that, there would be no nucleus. It would blow apart. The last force is the weak force. Again, this is going to take place inside the nucleus. It's what allows one flavor of quark to change into another. And so we typically don't talk about quarks in this unit. When we get to the nuclear stuff, the next PowerPoint that we take a look at, we'll take a look at it. But basically, the weak force is what allows a proton to change into a neutron and emit a beta particle, or to have a positron emitted from the nucleus. So basically, you have a situation where we used to think that the subatomic particles, protons, neutrons, and electrons, were the smallest that you could get. In reality, they are made up of smaller things, these things called quarks. There are different kinds of quarks, or different flavors of quarks. And so a proton is made up of multiple quarks. A proton is made up of multiple quarks. An electron is made up of multiple quarks. So as these quarks rearrange themselves or change from one to another, you actually wind up altering what you have inside the nucleus. And what allows those quarks to be together is the weak force. So like I said, it involves the transmutation of protons to neutrons. And this is really important because it allows deuterium, which is a hydrogen atom with one proton and one neutron. So it's H2, not subscript 2, but 2 for a mass number. It's what allows regular hydrogen to become deuterium, and deuterium is actually what undergoes fusion in the sun and obviously provides us with our energy. So that's a pretty important idea. It also allows you to have buildup of heavy nuclei, because that repulsive force, that electromagnetic repulsive force of the protons, are trying to push the nucleus apart. The weak force, again, helps the nuclei stay together, the weak and the strong force. And during nuclear decay, like I said, it allows one particle to be converted to another. So for example, when a beta particle is ejected from the nucleus, you may or may not remember what a beta particle is. Like I said, we'll get to that when we talk about the nucleus PowerPoint. But basically, if some sort of radioactive isotope undergoes a nuclear decay, it's because the weak force is being modified. So here's just a final summary of the different kinds of forces. So in terms of strength, you can see that strong force, very, very, very strong, but only over a very short distance. Like this is not, an atom is like an angstrom, which is 10 to the negative 12. And we're talking even smaller than that. So we're talking the distance between a proton and a neutron in the nucleus, essentially. Electromagnetic force can be positive or negative. It's got a strength, 130, 1/137th of a strong force, but its range is pretty big. Weak force is what allows the nucleus to kind of be modified a little bit. Its strength is less than the electromagnetic strength. Its range is also pretty bad. And then finally you have gravity, which has a very small strength unless you have a very huge mass. But for us, we don't, so it's kind of irrelevant. All right, so those are the 4 types of fundamental forces. Like I said, we are going to talk about the strong and the weak force when we get to talking about the nucleus. The electromagnetic force, you know a lot about already, so we'll just keep refreshing your memory on that.